Welcome. Thank you for joining us. My name is Chaz Spahn and with Adaptiva, and today we're going to talk about the top 5 pain points that administrators feel when working with SCCM and exactly how Adaptiva can help to counteract those. So first off, we're going to take a look at distribution point sprawl. This is one of the #1 pain points that most administrators feel when they start to talk about how to design and set up a full config man architecture. And the point is that we want to get our content as close to the clients as possible so that when they need to download content, it's not going to be going across WAN links and bringing our WAN links down to their knees. And so we end up having to design these big complex architectures to be able to get those distribution points and potentially branch cache or peer cache points closer and closer to those clients. And Microsoft has given us a few different options and technologies to help us with that, but all of them continue to include more and more infrastructure and more workload on the administrator to design, architect, manage, and maintain that infrastructure so that it continues to work for our clients. And so all of that is very, very costly. We start to look at the servers alone, the number of servers that we have out there. We're paying for that hardware. We're paying for server licenses because it's got to run server software on top of that. We're paying for the server management team to manage all of those servers, keep them up to date with patching, keep them up to date with all of our security policies and profiles. And we could end up with literally hundreds, if not thousands of these devices across our global infrastructure. One of our largest customers came to us with literally over 4,000 different distribution points that they wanted to try to cut back or eliminate as much of them as possible. With them, we eliminated all but one. So Adaptiva is going to allow us to get rid of some of that costly infrastructure and really take advantage of resources that we already have available to us. Now, when Microsoft tries to protect that WAN bandwidth, as I said, we're going to put that content out as closely as possible to the end user, but the end user still is going to end up at sometimes having to go across WAN links to get that. And so to do that, they took advantage of the Background Intelligent Transfer Service, or BITS, and gave us the ability to now protect that WAN bandwidth by throttling our throughput. So instead of being able to take advantage of all of the throughput that's available at the time, they're going to restrict us down to just 10% of that bandwidth, 15% of that bandwidth. And now the rest of that is available for other business traffic, but it's hurting us because now if we need to get that traffic, we're stuck dealing with that slim little slice of bandwidth that we've got to work with. Not only does that slow us down, but it's also very, very fragile. It can have lots of issues and errors that occur within it. And the good news with BITS is that it does have error correction. In other words, it'll pick up where it left off. But still, by having to constantly stop and restart, we're again continuing to slow down that traffic and getting it from point A to point B. So as I said, Microsoft gave us some other options. We've got branch cache, we've got peer caching. We've got delivery optimization now with their new bolt-on delivery optimization server that you can add to Config Manager. All of these are afterthoughts that kind of get added to the process to see, hey, we can take advantage of this or we can do this and hopefully reduce the amount of infrastructure that's in play by utilizing branch cache on our peers, utilizing peer cache on our peers. But again, these become architectures that we have to manage. I have to design them. I have to determine who's participating where, who's going to be my peer cache source, designate a backup so that I've got redundancy on all of those cases. So they do provide us with some ways of getting rid of some of that infrastructure, but they add on even more administration and design and management to keep that up and running. That makes it more difficult for us to be able to utilize this extensively. And of course, there's a massive bandwidth requirement. Why? Because every machine has to pull down content. And if many of those machines are across WAN links from their distribution points, then each of those machines is pulling that full copy across. Instead of only pulling one copy across and then utilizing it within that work group, they're going out and having to do multiple downloads, which is going to incur that huge bandwidth requirement. So how do we help with this? Well, first off, we want to get rid of that infrastructure. We want to get rid of all of it except for one, right? We always have to have at least one distribution point because Config Manager always has to find its content natively within Config Manager itself. So we do need one distribution point, but that distribution point is now going to cover the entire infrastructure, right? Every machine will fall underneath the boundary group that is supported by that one distribution point. And then from there, all of that content is going to be found utilizing the power of peer-to-peer. So gotten rid of all of that reliance on servers, reliance on server OS, reliance on the server team to maintain all of those servers, reliance on our config man team to make sure that content is getting distributed through the design that we've set up using different push distribution points, pull distribution points, branch cache, peer cache, whatever. We're losing all of that infrastructure and moving to a simplified world where we're using the power of peer-to-peer, the resources that are already there and being wasted, and using them in an intelligent fashion. What do I mean by that? So with those clients that we're going to support, we're going to install the Adaptiva client on those. That Adaptiva client is self-aware and it's also network aware. What do I mean by that? It's going to be communicating at all times with all of the other machines in the same subnet. So as you can see in this graphic here, each of these machines is talking to every other one. Now it does that by using broadcast communications. So it simply sends out and says, hey, I just downloaded this, or hey, I'm here, or hey, who's the RVP, right? All these different communications and questions that are going to happen within a subnet is going to happen using this broadcast communication. So it's very quick, very efficient. We're not utilizing a bunch of bandwidth and we're not ever going outside of our broadcast domain. So we're staying within our subnet, within that local switch or hub, and then communicating outside of that only at the times that we need to when it comes time to get content from across a WAN link. The beauty of Adaptiva products is that they all run on top of the Adaptiva Edge platform. And that brings with it all of the features and advantages that are built into the platform itself. Things like bandwidth optimization, things like how we cache our content on a local client. And so specifically at this point, what's going to come to bear is where do we hold that content? We want to get it as close to the client as possible, just like we did before, but we want to do it in a much more intelligent and optimized fashion. And so we do it by storing it right within the subnet, right on the other clients. So every piece of content that needs to come to that subnet is going to come down. It's going to go to 3 different machines. We're always going to have redundancy built into that. And we do that by building out first a 0 footprint cache on every single machine, and then pull those caches in together to create a virtual SAN. And just like any good SAN, we're always going to have that redundancy. So we'll always make sure that there's at least 3 copies that are available. So how does this 0 footprint cache work? Well, let's take a look at that real quick. I'm going to switch on over here to the lab, go to one of my clients here. And as you can see, if I look at this PC, I've currently got 40.2 gigs free. Now, if I right click on that and I go to properties and I say, great, let's take a look here. I've also got 40.2 gigs free. I'm going to use a third-party utility that gives us a visual view of our hard drive and all of the space that's being utilized on it. And with it, when I click this green star here to show the free space, again, we see that we've got 40.2 gigs free. So that's great. Now what I'm going to do is I've got my Windows 10 DVD mounted here. I'm going to go ahead and open that up, and I'm going to find the install WIM inside of the source folder. There it is. Nice big juicy 4 gig file right there. So I'm going to go ahead and right click on that. I'm going to copy it. And I'm going to copy that into the Adaptiva cache. Now, where's that located? Right at the root of our drive. So I'm going to go to my C drive, and right there at the root of the drive is the Adaptiva cache folder. Notice that it is a hidden folder. So users are only going to see this if they've actually made hidden folders and files available and viewable. Otherwise, it's going to be completely hidden from them. They won't even know it's there. I'll open that up, and I'm going to right click and paste that in here. So we can see that getting pasted in, watching that go through. If I open up, notice I've still got 40.2 gigs free, right? That hasn't changed. If I go back here and I go back to this PC, I've still got 40.2 gigs free. So I haven't taken away any of the free space. The user, the operating system have no idea that we just utilized an extra 4 gigs of that space. What does that mean for us? It means we get to utilize that free space without ever impacting the user, without ever impacting the operating system. And we don't have to worry about setting up quota-based caches or anything like that. We'll utilize as much of that free space as we need. We'll give it back in real time should that user decide to need it. If they start copying stuff down from the internet, maybe some ISO files, we're going to give that space back in real time right back to them. They'll never even know that we were there. Right? So that's why we call this a zero footprint cache. And once we've created those zero footprint caches, we go back then. Once we've created those zero footprint caches, we go then and create that virtual SAN, which gives us that redundancy. Make sure that we have multiple copies of content within a location. Now that's great. That's where we're going to put that content. But the next thing we need to look at is how do we get the content there, right? That network bandwidth that we were talking about, the whole reason we built out all that infrastructure was to try to reduce the bandwidth that was being utilized. So how does Adaptiva come to bear when we do that? Well, first off, again, let's look at the problem. There's hundreds of or potentially thousands of offices around the world, and not all bandwidth is created equal. Some locations might have gig connections and others may have just simple 512 connections. And so it's definitely not going to be the same thing trying to push it from one location to another. And the larger our infrastructure is, the more likely we are to have different levels of bandwidth available throughout our environment. It requires costly infrastructure at each location. And if we're having problems with what we've got built in, it's a matter of buying more bandwidth, buying at extremely high rates in some locations. So if I've got a global infrastructure and I'm dealing with remote countries that have got terrible bandwidth communications, I'm going to be paying quite a bit to be able to try to improve that to increase my rate. So what is it that we have to do? How do we protect ourselves against this? So how do we combat all of these high costs? Admins have to work hard to apply rate limits, determine when we can send content, when we can't, throttling that content down, which many points is under our control, and other times the network team puts those throttles in place and they're beyond our control. So it's all of this work that we have to do to figure out, okay, just exactly when can I send it? How much can I send? Do I have to put a threshold around it that says if it's not done by this time, stop and we'll pick it back up tomorrow night? And how exactly to put all of those controls into place. So it's a lot of soft costs and administrative workload to be able to get all of these things put into place to make it work. And the beauty with Adaptiva is we don't have to worry about that anymore. We can send content at any time during the day and not have to worry about it interfering with other business traffic and not have to have that traffic throttled. So how do we do that? Well, we take advantage of a feature called predictive bandwidth harvesting. And predictive bandwidth harvesting is one of the features of our unique protocol that we put into play when we install the client. And what we're doing here is we're trying to combat the problem with throttling and the problem of interfering with other business traffic, right? That's what's happening on the config manager side. That's why we're using bits. And so how can we utilize all of the available bandwidth without impacting business traffic and without having to be throttled and restricted to that thin slice. So if we look at this top diagram here, you can see the non-Adaptiva solution. And this is typical of what we would see with a config manager solution. This top blue area here, that's our business traffic going up and down all day long. And that can be anything from HTTP traffic to voice over IP. It could be our SaaS applications, anything that's going on across the network and utilizing that bandwidth. So that's constantly going up and down all day long. Now, down here at the bottom is that throttled systems traffic. We're limited down to that little slice and never can go outside of that. And so even if we need to download more traffic, we don't get that opportunity to raise up our bandwidth because we're trying to protect the bandwidth for the business traffic. And what ends up resulting in there is the gray area here, which is all of our unused bandwidth, right? We're paying for it, but we're not getting to utilize it because as that business traffic goes up and down, since we're restricted into that slice, we can't go and take any of that unused bandwidth and take advantage of it. So that's exactly what we do with Adaptiva. With our harvesting technology, we're able to harvest all of that free space, that free bandwidth, and utilize it to accelerate our transfers. Now, the way that we do that is we're watching what happens as the content traverses the network. Our bandwidth protocol is using exclusively UDP communications, which means the sender simply sends that content and it's up to the receiver to control the flow of traffic. Unlike TCP, which would establish a session, and those two would constantly be going back and forth and negotiating. In this case, the receiver is complete control over telling the sender to speed up, slow down, or hold it right there. And so he's able to look as that traffic, that first couple of packets came across the network, what happened to them? Did they get thrown into router queues because there was so much other traffic that was going on? What was that other traffic that was going on out there? What's happening and how that bandwidth is getting utilized? And we can then react to that within milliseconds, right? Speed up, slow down, or hold it right there. And since we're talking about milliseconds, it's faster than the naked eye can see. So if we're looking at some monitoring tools, you're never going to see Adaptiva traffic interfere with any other type of traffic that's out on the network, because we will slow down, speed up as they make it available, or hold it right there if we've matched the throughput that they're utilizing. So we're going to harvest that free space, and that's what's going to allow us to get our content through so quickly. On top of that, we're also going to compress all of our content. So we're sending less data across the wire. So sending less data, doing it using more bandwidth whenever that bandwidth is available. This is what allows us to get our content through so much more quickly than native native config manager and any of its devices that it would put into bear. So let's take a look at what this actually looks like. I'm going to show you a quick demo here. What's about to come up on the screen is 4 different remote desktop sessions. The 2 on the left are servers. The 2 on the right are clients. They are separated, the clients from the server, by a T1 line. The 2 on the top is just a standard file server and a client that's going to download a file from the file server. The 2 on the bottom will represent the Adaptiva sender and receiver. And so you're going to see this little utility here pop up in the bottom 2 windows. And what I want you to pay attention to is this green line right here. Watch how it fills in and how it then backs off as bandwidth is getting utilized. So I'm going to go ahead and kick this off. As I mentioned, there's the 4. So we're going to start the flow of Adaptiva traffic here on the bottom. Watch the green line. It's going to stair step its way up there. Notice it doesn't just go from 0 to 100. And in fact, it never goes to 100. See how it's not completely filling that in there? And it's bouncing around because there's other systems traffic that's being utilized. But now we're going to go ahead and download a file on the top machine here. So drag this out to the desktop. Now watch, as soon as that GUI pops up on the top, the bottom, we've already started slowing down our traffic, right? Again, faster than the eye can see. That GUI will disappear. We'll automatically have already started picking up our speed again and resuming the full bandwidth of that available bandwidth of that WAN connection. We'll start a bigger one here. Again, we slow back down. Now notice I'm not going down to 0. I've got a trickle that's going through there. And like I said, I never go to 100%. Why is that? Well, I never want to go to 100% because I always need to allow that other business traffic to get started so that I recognize, oops, somebody needs it, back off. Likewise, I always need to be sending a couple of packets through so that I know when that bandwidth becomes available again, and I can go ahead and resume the faster traffic. So there we go. GUI disappears. We've already started to resume using that bandwidth once again. So this is happening in real time, measured in milliseconds, faster than the naked eye can see. So when somebody's looking at a monitoring tool, looking at how this is being utilized, it's very easy to tell that Adaptiva is a good neighbor and is always going to allow other business traffic to get through there before we're sending our systems management traffic through. Now notice at the bottom of the screen here, it says, never bother the network team again. And that's exactly what we're trying to accomplish here. We want to work together with the network team, not against them. We want them to understand how this protocol works. They can see this demonstration for themselves, and they can use their own monitoring tools and notice that no matter what they throw at the network, Adaptiva will always slow down to allow that traffic to go through first. And as soon as it's done, Adaptiva will then pick back up. And that's how we solve the network throughput issue. Now, the next problem is reliability. And a big complaints that ConfigMan admins always have is it's not always the most reliable platform for getting our content out to our devices, right? Not only do we have a fragile infrastructure to get it out there, we've got a fragile protocol in bits to try to get it out there. There's also inherently a known issue with just the health of the clients themselves, right? So how do I make sure that my SCCM client is working properly and actually pulling content when it's supposed to? So we needed a way to combat all of these different issues, right? Delivering content, like it says here, it isn't a nice to have, it's got to happen. I'm relying on this infrastructure to get my security patches out there. I'm relying on it to get out critical software that my users need to be productive. I might have critical software out there to protect my environment. Could be another security issue, right? No matter what it is, there's so many points of failures and dependencies that Config Manager puts into play that can cause us issues. And we need a way to be able to, again, combat that and ensure that this content is really going to get from point A to point B every single time. The third problem that we always have is polling gaps. So when I install Config Manager, out of the box, it's got a 1-hour polling cycle. So the client is responsible for going up to the server and saying, hey, is there anything new for me? Is there anything that I should be doing, anything that I should be installing? And so that polling interval causes us yet another gap in coverage. And so many admins will decrease the time involved with that. So they'll lower that down to 20 minutes or lower that down to 15 minutes. Well, what's the negative side effect of that? Well, now I've got machines that are constantly going up and polling, even though there's no changes for them, right? 95% of the time, there's not going to be a change. And so I'm flooding the network with these polls just to find out whether or not there's content there. Now, if I've got a few hundred clients, that's not going to be a big deal. But when I start talking about tens of thousands of clients, that's a lot of bandwidth that's getting utilized and wasted in checking on something that's not going to be there. So Adaptiva helps in a couple of different ways here. First, within one site, we have the policy bandwidth management capability. And what this does is it turns Config Manager from a reactive into a proactive. In other words, instead of waiting for that polling interval, Adaptiva is going to tell that client something's changed, you need to go up and get your change. We're not sending them the actual change. We're just sending them a notification that says there's something in your inbox, go and check. You need to go and apply some kind of policy or install some kind of software. So again, we're turning that from reactive to proactive, and we're eliminating that polling cycle, we can now set that polling cycle inside of Config Manager to be its maximum at 24 hours. So once a day, it'll go up and do one spurious check to see if there's anything out there. The rest of the day, we're going to rely on Adaptiva to let us know that there's a change that we need to take advantage of. The second feature that Adaptiva brings to this is Adaptiva Endpoint Health, another product that can be utilized to constantly check on the compliance of your endpoints to make sure that they're meeting up with your expectations for all of your security posture, for all of your endpoint configuration, as well as for the client health of SCCM. We can check, is WMI responding properly? Should we reset WMI? Should we reinstall the Config Manager client because something has gone fatally wrong there and it's no longer responding? So Endpoint Health gives us that ability to go through there and check on, is bits are operating properly? Is Config Manager client operating properly? Is WMI responding the way that it should? All of these things and many, many more things can be checked using Endpoint Health to make sure that the system is continuing to work reliably. Number 4 is the difficulty in setting up content boundaries and boundary group management. As a config manager, admin working with a global infrastructure, you know how difficult it is to have to go and set up all of these boundaries. You're setting them up using IP subnets, you're using IP ranges, you're using sites and services within Active Directory. You're using some mechanism to identify which machines should be grouped together within a boundary. And then for those boundaries, which of those boundaries should be grouped together into a boundary group. And then we apply management resources to that. So management points, distribution points, peer caches, and so on. So if I've got to constantly manage all of that as everything changes throughout my environment, I'm always adding new things in there. I take a chance again of missing something. If the network team doesn't tell me that they just set up a new subnet, set up a new office in Zimbabwe, set up a new campus center in Boston, whatever the case might be, I'm losing that period of time of being able to manage those clients until I get that information and can create a boundary and then add it into an appropriate boundary group to get them covered by all of my config manager resources. So I have to be responsible for mapping all of that out, building out the boundaries and the boundary groups, and ensuring that I've got complete coverage for my entire infrastructure. With Adaptiva, I no longer need to worry about that. Now I can set a single all-encompassing boundary and boundary group for the entire estate, right? One thing manages everything. I can create an IP range of 0.0.0 through 255.255. And now I'm guaranteeing that every client is going to be covered with a boundary or a boundary group. So how do I now manage getting that content and getting it from a source that's closer? That's going to happen within Adaptiva. And Adaptiva uses a network topology that allows you to optimize it and make sure that it's working as efficiently as possible. But on top of that, we're also going to automatically generate topology whenever something new pops up. So if the network team does set up that new office in Boston, well, as soon as it comes onto the network and an Adaptiva client is present, we're going to capture that it's coming from a new IP range. We're going to build out a brand new location within Adaptiva. We'll name it auto and the network ID of that network, of that subnet. And so it makes it very easy to identify that we've got an automatically generated one here. If it's an entire location in Boston and I've got 12 different subnets that are set up there, we'll end up with 12 different automatically generated subnets. That's fine. They're all going to be working. They're all going to be operating properly. They're all going to share content within those subnets. Now, is it completely optimized? Probably not, because those subnets probably are able to talk to each other using the LAN in that local office. And so we want to be able to take those different subnets and combine them together into a single location. And I can do that very easily by simply renaming one of those automatically generated, and then merging the other ones into that one. So I'll pick the first one, rename it to Boston, take the second one, merge it into Boston, third one, merge it into Boston, and so on. And now all of those IP ranges become a part of that location of Boston, and they will all share content between each other using LAN technologies. And whenever they need to get content, they will reach across the LAN reach across the WAN and get that content from its parent office. Now, by default, these auto-generated offices will be child offices of the central office, wherever that server is located. So again, we can make this more optimized by moving that if appropriate. So here I've got the data center in America. I want to take my newly generated Boston and I would bring it down and make it a child of the America data center. So it would be a peer with New York and Miami and Houston here. So I lay this out and I control my network topology so that I'm controlling the flow of what's going over the WAN, what's going over the LAN. And that's very simply, whatever's in an office uses the LAN, whatever goes between offices uses the WAN technology, uses that background protocol using the predictive bandwidth harvesting that we just spoke about. So it knows where our endpoints are. It's going to deliver content directly to where they need to go. It's going to utilize LAN technologies whenever it possibly can and protect that bandwidth whenever it's going over a WAN link. So let's take a look at what that looks like. We're going to switch on over to the lab environment here. And we're on our server. What we're going to do is we're going to go to Assets. We're going to go to Devices. And here I can see all of the devices that are in my lab right now. Now I want to see how they're grouped together. So again, I can go to Assets and I can go to Locations. And this is that infrastructure that we talked about. And if I view this as a tree, I can see I've got my central office. Below that, I've got an auto-generated office of 1220. I've got another auto-generated office of 192.168.1.0. I've got my Plano data center and my Seattle data center. All right, so if I expand those out, I can see the different sub-locations that are below those. Each of those, again, is defining all of the machines within this location should use LAN technologies. Whenever somebody in Houston needs to get content, they'll go to their parent office, which in this case is the Plano data center. So they'll take one step up to the Plano data center and try to get that content from there. If they don't have it, then they would go up to the central office to get that. So we walk from child to parent to its parent to its parent all the way up until we get to the central office. All right. And if I get an auto-generated office, it means, again, I found a client that's on a network that I didn't identify previously. So now I can go and work with my network team and say, hey, this network just popped up. What is it? Oh, sorry, we meant to tell you about that. That is a new office that we just opened up in Austin, Texas. Okay, great. I can right click on that. Excuse me, not right click on it. I can left click on it. That shows me which devices are inside of that office. And I can go back and say, all right, I'm going to edit this. I'm going to go back to my tree view, or excuse me, my table view. And I'll come over here and say, I want to edit this office. I can change the name and say, this is Austin. I can give it a description, which you can see I've done that before. All right. And now this will be my Austin location. All right. So, and the last pain point that most config manager admins will discuss is the complete lack of visibility and control into what's going on in their environments, and the lack of reporting to know where content is or isn't, where did it successfully go through to. I can see that as far as distribution points go, but I can't see it all the way down to the endpoint. So again, there's that limited visibility into where it's currently being transferred. For example, if the network team comes to me and says, I've got bandwidth hydration on my Singapore link, are you guys sending anything there right now? Can you stop it? right? I've got very limited visibility into figuring that out. I've got to go through all of the different open jobs right now and try to figure out if any of them are going through to Singapore right now. And if I do find it, my only option is to stop it, to cancel that job and then resume it again later, right? I don't have any other levels of control in that. I can't pause it. I can't slow it down. And so just no control once I do find it. And then after the fact, if I'm trying to go through and look at what was going on from 12 o'clock to 1 o'clock today, or I want to see all of the content that's been transferred to a certain location, I don't get visibility into that. It doesn't exist within the config manager environment. And so Adaptiva adds all of that to it, right? There's 3 different actual ways that we can see the content within our environment. The first way is live flow. Adaptiva's live flow is going to show us what's going on right now within our environment. What content is getting currently transferred from what location to what location? What is the priority of that traffic? What is its current status? And it allows me to take control of that. I can pause those transfers and then resume them later. I can change the priority so that a different piece of content will start to get transferred now and that this one will go at a later time. I can still cancel it if I need to. And I can even take a drastic measure and change it from the background WAN protocol and change it to the LAN protocol so that that content gets out there much, much faster, knowing that it's going to impede other business traffic, because now we're taking away that protection and instead we're applying our acceleration technologies to it to get it out there as quickly as possible. So let's say there's a 0-day vulnerability, and that's the most important thing right now. Doesn't matter if phone calls get disconnected, get this out there right now. So we do have the ability to accelerate the distribution of that content by utilizing the foreground adaptive protocol. The other thing we can do is we can look at content management. Where has it already gone, right? So this, now we're looking at the past. I can see that this has been distributed to this location. I can see it went to these specific machines in that location. And then I can take that to another level and look at all of the reporting that we build into Config Manager that goes into SSRS and shows up directly within the Config Manager console. And it's going to give you hundreds of different dashboards and reports that are going to allow you to answer specific questions, such as show me all of the content that has been downloaded to this location. Show me all the locations that have downloaded this specific piece of content. Show me what was going on during the hours of 1 and 3 p.m. And I can see all of the different transfers that were occurring for a location within that time frame. So just hundreds of reports that are made available to you. So once again, let's take a look at how this looks and how you can utilize this in your own environment. I'm going to switch on over to our lab environment one more time. And I'm first going to go to our workbench and look at the content distribution status perspective. This is the one I told you about where I can see the past. Now, right now, I'm going to play with my SCCM package for Office 365. I can see that it's been distributed to Seattle location, to the auto-generated office, and to my central office. And as I click on each of these, I can see the devices that have received this content. So I know exactly who has it and who doesn't have it. Now, what I'm going to do with this is I'm actually going to get rid of it. So I'm going to switch on over here. I don't have it open yet. And here's my SCCM packages again. I'm going to find Office. There it is. And I'm going to right click on that and I'm going to say unpublish this content. You can see it changes its icon there for a second while it's doing its unpublish. And we should end up with a new flag here in just a minute showing us that this is unpublished content. And what it's doing is it's removing it from all of the locations that have had it before. Very, very quickly and efficiently, it gets rid of it from all of the locations that have already downloaded this. So if I go back to my content distribution, click away from that and come back, I can see everything is now cleared out and deleted here. And there we go. We now have our yellow flag that this has been unpublished. So now what I want to do is I want to push this content back out to all of my machines again, and we'll watch it as it goes across the network using live flow. So I'm going to switch back over here once again. And I'm going to right click on that and say, publish this as Adaptiva content. Again, it's going to change icons as it goes through the different parts of publication. And once that's ready, we'll do a content push to get that content out to all of those machines. And there we go. Now that that is completely published, we can see that the icon shows us that it's published to the server as well as to the cloud. Now we can go ahead and do a content push with that. And for that, I'm going to switch on back over to our web portal, and underneath content push, I've got a push policy here for Microsoft Office. And I can see that this is pushing Microsoft Office 365 for my deployment project. It's pushing that 365 package that we were just messing with. It's going to push it as soon as possible to Washington computers. So I'm going to go back here, click on this and say run policy. So that's going to run this policy immediately. As there we go, policy has been dispatched successfully. And now I can go here to my WAN downloads. When I first come in here, it's not going to show anything, right? I have to make a selection to be able to display my live flows. Now I can choose to either sort by content or just filter by content or filter by locations. In this case, it is a package that we're working with. And so I'm going to go to Config Manager Packages, and I can pull this over. There's my Office right there. So we're now filtered on that package, and we should see where this is flowing through. Refresh, there we go. So we've got 2 active transfers going on right now. 1 source location, 2 destination locations, 3 gigabytes total of transfer because it's a 1.5 gig package and it's going to 2 different locations. So that's 3 gigabytes of total WAN transfer. If we scroll on down, I can see here's the content that's being transferred. It's going from the central office to Seattle. It's also going from the central office to that auto-generated office. And those are the 3 different locations that we saw when we started this in the content distribution. It had been distributed to those 3 locations. And so I can see my status, what percentage it's at, how much time is remaining. Actually, there we go. Let's get our refresh at a more consistent level here. So I'm going to refresh this every 5 seconds. So we can see the percentage of download that's already occurred, how much time is remaining, what the priority of that transfer is, what the transport protocol is it foreground or background, and what is its current state? Is it active or is it waiting? Now in this case, they're both active because we're looking at 2 different locations downloading the same content. So there's no conflict there because we only can conflict within the same location, right? There's a single download occurring at any point in time per location. Now I can go onto these and I can pause it. I can override the priority, make this a higher priority so that it goes before something else. Or I could make it a lower priority so that it goes after something else. I could do a transport override and change it from the background to the foreground. Remember I told you if I've got that 0-day bug and it's an absolute emergency that I get this out there now ahead of anything else and more important than any other business traffic that could be occurring, then I can go ahead and do that and I can do a transport override. Or I can cancel the transfer in its entirety, just like I could within Config Manager. So much more levels of control that I don't have if I'm looking at Config Manager by itself. Thank you very much for joining us today. We hope that you've learned some valuable information here, and you can find ways to apply Adaptiva products to your own environment to save you a lot of time and money. Thanks again.